Right. Hello, everyone. Welcome back to our IAGB Youth Podcast Series. I'm Shourya Gupta, I'm joined alongside Nipun, Sarina, and today's guest speaker, Mr. Donovan. Today we'll be talking a little bit about neuroscience and its neurological diseases. So a quick little intro about IAGB. IAGB Youth Podcast Series is a series where the youth, me, Nipon, and Sarina, are joined with our guest speaker to talk about interesting or controversial topics in today's society. Neuroscience is definitely one of them, with its popularity rising amongst the youth. Yeah, we can go ahead and introduce ourselves. As I said, I'm Shourya Gupta. I'm a high schooler, and I enjoy talking about neuroscience, and I play chess occasionally.
Everyone, my name is Nipun. I'm also a high schooler. I like to play football. I play the trumpet, and I'm passionate about broadcasting currently.
Hello, everyone. My name is Sarina. I'm in 8th grade and I love acting, singing, and socializing.
And hi, everyone. My name's Donovan. I've been a high schooler for 32 years now. And so I'm a high school science teacher, actually, one of Shourya's teachers.
Yeah, I had Mr. Donovan freshman year. I would definitely say I enjoyed his class.
Thank
But
you.
yeah. So let's get started. The main kind of topic I want to start off with is why is it so important to study neuroscience, especially considering how technology has improved within the last decade or even 20 years? Mr. Donovan, could you provide some insight?
Well, I think one of the most obvious things is since a lot of neurodegenerative diseases are afflicting the elderly more than anyone else, the study of neuroscience becomes really, really important because so many people are surviving long enough that you start to see the manifestations of it. And so, where you think of Alzheimer's and diseases like that as an old person's problem, well, we've got a lot more old people than we used to. And so, it just makes sense that more and more people are going to be interested and motivated to find the underlying issues that occur there.
Yeah, an interesting statistic and a really, surprising one now is that more than 1 in 9 um, people ages 65 and older are diagnosed with Alzheimer's. And it just shows you how widespread this disease is amongst the elderly generation. And I think that, as you said, makes it increasingly important that, we continue to do research, we continue to do discoveries on this topic so we can, better the health of our own community.
You
So,
know,
oh, sorry, you can go ahead.
I know that's a great point. I was saying, Shoria. I just had a quick question for anyone of the younger age that may not be totally familiar with neuroscience. I was wondering if Mr. Donovan could just quickly explain what exactly is neuroscience and how it's applied in today's society by doctors and other medical professionals alike. That would be great.
Well, neuroscience is really the study of the brain. That's its probably most broad definition, and that's been very, very difficult for all these years because it's not something like you can just open up and take a look at. So when we look at neuroscience, we're looking at the chemistry of the brain, we're looking at some of the physiology of the brain, looking at a lot of different aspects that allow us to be us. And so neuroscience itself is an extremely large subject. When we get into neurodegenerative diseases again, we now have a lot of tools that were never available before. Just the idea of the MRI and other ways that we can probe and uh, basically study a human being's brain without disturbing it has allowed for a lot of different advantages, a lot of different advancements to occur. And neuroscience can be the study of behavioral things as well as physical things. It is huge.
Yeah, specifically if we go on Alzheimer's, it's talking about specifically the brain and how the neurons, the brain cells get degenerated, they break down and they stop to function. But neuroscience doesn't have to do just with the brain. It's really just the entire nervous system. nerve cells, that are present in your gut or that are present, near your heart have a really serious effect on how your brain can function, because your brain is connected to every single part of your body. So if there could be an infection, a degeneration somewhere along the line in your nervous system, if there is a problem, that could have serious effects with your brain. And again, that makes it so much more harder to research, because it's hard enough to diagnose, or at least find early symptoms of a specific disease, but it's even harder to trace it down to where it starts. A lot of these neurodegenerative diseases, ALS is an example, which reduces movement in your muscles, or Huntington's disease, which is again the degradation of the nerve cells in your brain. It's hard to figure out when those start, or it's hard to figure out when you can, stop that disease from progressing. And yeah, that just makes it even harder to study.
Mr. Donovan, could you tell us about some of the challenges surrounding studying neuroscience? Obviously, you can't dissect someone's brain while they're alive. So is there any challenges kind of surrounding that?
That's actually one of the things that I find most fascinating, is that it used to be when a person had Alzheimer's disease, probably the most famous of neurodegenerative diseases, um, they couldn't officially be said that they suffered from Alzheimer's until they had died, until a doctor was able to actually look and inspect the brain and say, yes, this is showing the all the aspects of an Alzheimer's patient. They could say they're showing characteristics of Alzheimer's, it is most likely Alzheimer's, but they couldn't definitively say it until they could take the poor person's brain out and look at it. And it's true with a lot of these different neurodegenerative diseases. We have things like multiple sclerosis, we have Alzheimer's, ALS, Huntington's disease. A lot of them manifest in a way that have similarities, but then have relatively marked differences at the same time. And so, as Shourya had said, trying to get to the root cause, the root focus of any of these is very, very difficult when you can't get to that root, literally. With a broken arm, you can see where the break is. And even though you don't have to open up the arm to see it, we have enough tools that allow us to be able to fix it. And with someone who has Parkinson's disease, that's not true. They know the general area, and they're doing a lot of work to try and figure out that general area and what it does. But it's still, because it was so invasive and it's such an area of the human body, impossible to fix mechanically. So we're looking at fixing things chemically, fixing things more with different types of enzymes, different types of hormones that would either abate, relieve, or repair. And all of those things are still not as far off as they were when I was your age, but they are still pretty far off.
Yeah, and again, to add on to that part about how it's so difficult to, find that right spot where it started, you can't, figure out that somebody's having it because you can't study it. And it's not able to be detected until those symptoms show up, until you can start, guessing that this person might have some form of Parkinson's or Alzheimer's. And even something like Huntington's, where that loss of motor function, or even psychological function, that could start as early as your 30s or 40s, and there's no way of telling that when you're a teenager. And again, that's one of those roadblocks that there's nothing really we can do right now about it until further scientific discoveries have been made.
Yeah, you led into those scientific discoveries. we definitely have made definite progress with neuroscience and these neurodegenerative diseases, how to detect them, how to treat them far in these coming years. But what exactly have been those technological advancements that have allowed us to make these diagnoses or formulate these treatments? I know you touched on CT scan, Mr. Donovan. Has there been anything else that has either come across in these past years or we're looking forward to in the next coming years?
One of the things that I find most fascinating, and I'm going to use the wrong words here, I'm going to describe it as best I can, but I know there are people out there that can describe this much better than I. If you think about, let's take an Alzheimer's patient. So there's certain mechanics that occur within the brain, these beta amyloids and these plaques develop, and that's what creates the effects of Alzheimer's. Well, you can't just go in and clean it. You can't go in and find out why these plaques are developing. You know, they're right now, they're not developing in me, they're not developing in you guys. So it's happening to that individual person. And what they've been able to do is actually take some cells from that person, take some skin cells, take some cheek cells, and revert those cells back so they're not specialized anymore. They actually, as the cells keep dividing, they revert them back till they become a stem cell, which is kind of it's the do-it-all cell. It's the first cells you were made from, and they could change into whatever was needed. So when a child is in development, when a zygote is in development, I should say, the cells are all pretty much the same, and then they start to specialize. Some become cardiac, some become nerve, some become skin, some become hair. And so they can take someone from an adult, revert those cells back to their stem cell stage, and then through a series of different, again, enzymes that they introduce, different types of criteria they give it, make those cells turn into a nerve cell or a cardiac cell or whatever they want it to be. So you can now, which we couldn't do even 20 years ago, you can take cells from that patient and you can grow them so you get a ganglion. So you have a group of nerve cells, and now you can see what type of different techniques you can use to actually affect the Alzheimer's that's affecting that particular person. So you're going basically to true personalized medicine that way. So the fact that we can revert and then change the cells into the specialized things like a nerve cell is, again, earth-shattering. It's the way this is going to be cured, in my opinion.
Because there's no way to heal a nerve cell or a neuron. There's no way, because unlike a regular skin cell or a regular, tissue cell, those can be healed or they can be, replaced. But nerve cells, especially ones in the hippocampus, they carry memory. Those, if they are replaced, that memory is lost. But even with the stem cells, that's a huge advancement in at least slowing, if not maybe someday stopping these diseases.
Right. If you create a new medicine, and you can check and see if that medicine actually affects the new ganglia cells, and if it stops any beta amyloids from being produced or being, really should say, glomming together, then you can say this is worth trying on the actual person. And it might be different for me as it would be for you, because it might be that specific genetically. So that, to me, that's like the number one advancement in terms of this. Another huge advancement that I've witnessed in the last 20 years or so is just the idea that instead of saying Alzheimer's, Parkinson's, ALS, they're saying neurodegenerative diseases. And you're having these centers built, like the Ann Romney Center at Brigham and Women's, that is a conglomeration of specialists but these specialists are working near and with each other, so that if you are a Parkinson's researcher and I'm an Alzheimer's researcher, and we sit down and have lunch together and start talking about what we've been doing in the lab, I might pick up something from you that is a good idea to try with my research. Or we'll have weekly or monthly meetings updating everybody what's going on. Since everything is a neurodegenerative, which means it's generally coming from the same place, and we're looking at the different specifics, you can get so many different ideas from people that they used to think were just, a completely other discipline, and they're not treating it that way anymore, which I think is I know it sounds like a social advancement, but I think it's an essential advancement to this.
Could you tell us a little bit about how neurodegenerative diseases develop?
It's really difficult to say. Some of them are genetic. So you can have Alzheimer's in your family, but that is not always the case. Actually, the majority of Alzheimer's patients, it just kind of pops up. And the same thing happens with Parkinson's and ALS. Those are the three that I'm most comfortable talking about. Realize I'm a high school teacher, I'm not an expert. But there is some genetic proportion to it, some hereditary proportion, but a lot of it just sounds sad to say, but just pops up. There's just, I haven't figured out the reason why.
Yeah, a lot of people are linking it to age as the neurons get more used and, more, I guess, weakened. They start to, underperform. The mitochondria start to, produce less ATP and, those neurotransmitters that are like the basis of the communication. Those start to, become less effective. And I've heard about cases where, the brain actually shrinks in size because they're losing that function, and then the space between the neurotransmitters are getting shorter to compensate for the loss of movement between the neuroparticles, and all of that. It may be right, it may be wrong. The 3D imaging of the brain that scientists have come up with recently, it's the best they're doing right now to try to figure out why is it that with age or by genetic or by some environmental factor these diseases are generating.
Yeah, I want to tilt back to the point Mr. Donovan made about stem cell therapy. I know he's expressed great hope for that in the future. There has been a lot of promising leaps made in that field in these past years, but there also have been some naysayers of the therapy saying that their potential may not work, or I even heard the Food and Drug Administration has warned against potentially illegal or not properly treated stem cell therapies. So this is more of a scientific question rather than one only about neuroscience, but how do we toe that line between innovation and safety when we're dealing with these new innovations such as stem cell therapy?
It's difficult. And just so you know, I don't know a lot about stem cell therapies. What I'm talking about is using stem cells as a model,
No.
And using that model for the individual patient. But it is extremely difficult. And one of the best things scientists can do is stay connected and stay involved with everyone in that community. If you hear like something's being done at this lab and they're not letting anybody know about it, that's when you get frightened. What you want is a scientific community that is open and free to share ideas, open and free to share discoveries that they've had, which makes it difficult sometimes in a what would be considered a capitalist society, because some people may want to profit from a therapy that occurs later, and that's not how good science works. Good science works into what do we know, how do we know it, how can we communicate it, so that everything else can go from there. I know there was a lot of moral objection with stem cells before they could take, mine, and revert them. And the stem cells originally, the only ones they could get were from aborted fetuses. And there's definitely a moral issue there. Some people thought it was fine, others thought it was terrible. And that idea of a slippery slope of having fetuses just to create stem cells, no one really would ever want that. And so what relieved that pressure, what relieved that was the fact that we can now, through a series of different enzymes, take anybody's cells and make them go to stem cells. So that moral quandary, I think, is closed. I'm glad I didn't have to be part of that moral quandary either. I'm sure it was very difficult for everyone trying to say this has huge potential, and yet what is the cost there? In terms of using stem cells for making people think they're younger or things like that, I don't know enough about it. I mean, I can just sit here and scoff and say we're as old as we are. Let's just admit it.
Yeah, to sort of tag on to that morality issue, stuff like gene editing, there's CRISPR that's been floating around, and people have debated countless times about the morality about it. This is just my opinion, everybody has their own opinion, but I think that this, in the right hands, could be a major, advancement using maybe genes, because if these neurological diseases are linked to hereditary reasons, and using those gene editing softwares could be, maybe a next big thing.
Yeah, and yeah, CRISPR again is that if people are open about what's going on and share ideas, I think what will happen is we'll naturally slow down before we get to those terrible ideas of designing, what is it called, designer babies and things like that. And really, we talk about how CRISPR is so easy. Well, it's so easy for a lot of those experts. I mean, it's still a relatively complicated, difficult thing for most labs to do. And again, as long as people are communicating what's going on, I don't think we'll have an issue there.
Yeah, and it all revolves back to that open shared community that you talked about earlier, like the Deanne Romney Center. It needs to be that scientists who are, maybe a bit too capitalists or a bit too, into their own gain, they need to kind of broaden their field and share their research with others so that as a community they can, help progress.
And honestly, 99, this is a made up statistic, of course, 99.999% of the people doing the research are doing it for the right reasons. They're doing it to further the health and wellness of the people and the organisms that exist on this world. So I take solace in the fact that a lot of the research is done in academic circles. Almost all of it. When I say Brigham and Women's Hospital, you have to understand that's also affiliated with Harvard and with MIT. These people, it's a teaching hospital. And so the idea that you're staying in the academic circles, I think, is this very strong safety net to keep things going, progressing as well as they can and as safely as they can.
Yeah, I think that's, again, to emphasize the importance of collaboration, along with academic research, whoever or the scientists that are doing their own research. I think if they work in tandem with, all these other different research groups, that could again be extremely progressive in terms of the developing treatment, if not a cure. Cure seems like a kind of a really far reach at this point, but maybe someday.
I'm a lot more hopeful of a cure than I was 10 years ago of all of these things. Some of these diseases in neuroscience, these neurodegenerative diseases, are horrific. What happens with an Alzheimer's patient is that person basically gets trapped within their own brain. Or if you talk about a Parkinson's patient, that's a person who's losing that motor control, which you've all had that experience of even just having an arm fall asleep, and the panic of I have no control over that. I have no control over that. I think about that being your day-to-day life. It's much worse than an arm falling asleep. Someone who's suffering from Lou Gehrig's disease, the same thing. That these are just such horrific things that we want to find a cure for them. Yes, we'd like to identify and relieve the stresses on them, but the cure is definitely the goal. And I am hopeful. I'm very, very hopeful because of people like who are working at Brigham and Women's Hospital and the Cleveland Clinic and other areas all around the world that this will happen.
Yeah, that's really great. I was just thinking how some people might be listening to this and thinking that, hey, neuroscience is really interesting. I want to be one of these people that maybe one day finds a cure to one of these neurodegenerative diseases and makes the world a better place. So what would you tell that high school student right now if they're thinking about this, but they don't know where to start? They don't know how to get involved in research. They don't really have that much of a base in neuroscience or many resources to talk to. How can they sort of start that network or get involved in research and what they're passionate about?
So one is, the cold call. If you're truly interested in this, go online, look up a place that's nearby, find a doctor that's doing the research, and call her. Just call the person's office and say, hi, my name's Sarina. I'm very interested in this, and I would love to just sit down and talk to you about it. And that's really what my students have been doing for the last 10 years. And it's amazing how many people want to communicate that to you. I've had students who are very lucky enough to actually work in some of these labs, both as high school kids and in college, but they all started with a cold call or an email, which is what more normal people do now, is emails than phone calls, just saying, I'm interested in this. I would love to talk to you about it. And you'll be really impressed with how many people will respond back to you that way. In school itself, obviously you're going to be taking biology. Chemistry is really important too. When you take chemistry, what you'll find is, a lot of the mechanisms that occur are chemical mechanisms. And so having that under your belt before you get into college is a great thing as well. But yeah, just email them. They're very nice people. Remember, they're trying to save the world. Usually those aren't jerks.
Yeah, and maybe that's all it takes, a cold call or a cold email, spark your own interest and, pursue research. And I think that's a big point nowadays that, people have so much access to all these different resources, especially the internet, and there's so many different ways you can, get yourself involved by just reaching out or by just learning more through, whatever websites and resources are available to you. So, Mr. Donovan, just one last thing. There's one kind of inspiring or, solid message you would like to give out to the youth that are listening. What would that be?
Be lifelong learners. Never stop learning. This is a mountain you will never get to the top of, ever. And you shouldn't. Because as you learn more and more and more and more things will become interesting to you. That is my mantra. That's how I go to sleep at night. What did I learn today? And thank you guys very much for giving me the opportunity to speak with you. I really appreciate it.
Yeah, it was definitely our pleasure.
Thank you so much for coming, and that advice, I definitely will use that. Thank you.
All right.
All right, I enjoyed speaking with you all. Any last remarks, anybody?
Well, that's it. I just wanted to say thank you so much to everyone listening, and thank you so much to our guest, Mr. Donovan. And we hope to continue the conversation about neuroscience and science in general in the future.
Yeah, thank you so much, everybody. been a great episode. And again, thank you for joining.